The 17th question says that show that the height of the cylinder of maximum volume that can be inscribed in a sphere of radius r is this. Height of cylinder of maximum volume inside a sphere. Okay, also find the maximum volume. So we are talking about a sphere which will look like a circle in 2D, and we are talking about a sphere. Okay, this is what a sphere will look like inside the, this is what a cylinder will look like inside a sphere. This is, okay, radius r of the sphere is this. This is the height of the cylinder, let's say, okay, and this here is small r, which is the radius of cylinder. Similarly, we can have this r, and we can have similar things over here, small r, and this. This becomes h by 2 actually. For the cylinder, this becomes h by 2, as you can clearly observe, right? The center of the cylinder and the center of sphere will coincide because this is a cylinder, right? This is what you have. Show that the height of the cylinder of maximum volume, V max, that's what we are supposed to deal with, that can be inscribed in a sphere of radius r is to prove height is equal to 2r upon root 3. That's our target, right? Okay, and what else? Also find the maximum volume. V max is equal to question mark, right? What is the relation between small r, capital R, and h by 2? You see that this is 90 degree. So r square plus h square by 4 is equal to capital R square. And what is the volume of sphere? This is pi r square h. Okay, and I can replace this r square by this particular term, pi h times capital R square minus h square by 4. Okay, this is pi r square h minus pi by 4 h power 3. Once you have written v in terms of h, you can differentiate v with respect to h. This becomes pi r square minus, this is 3 pi by 4 h square, right? And once you have done with this, then you can simply equate it to 0. Get that h square is equal to 4 r square upon 3. This is what you have. H square will be equal to 4 r square upon 3, which tells me h will be equal to 2r upon root 3. This is the critical point. Why not take the minus value? Because h is supposed to be positive. This is the height, right? So we're not considering the negative value. And if you observe, right, the critical point is 2r by root 3, and you have one value 0. So before 0, this will be smaller quantity, right? This will be smaller. Therefore, this will be overall positive, and here it will be negative. So increasing and decreasing function will tell me that you have a maxima at this particular point, right? So volume maximum at h equals 2r by root 3. This is what we wanted to prove, hence proved. The next thing that you are interested in finding that V max, right? So let's find the maximum volume. Let's find V max is equal to what? This is pi r square h, which is equal to this expression over here. And since small h is 2r upon root 3, we can easily find that as well. So this is pi into r square into h, which is 2r by root 3, minus pi by 4 times h power 3, which is 8r cube over 3 root 3. What is that equal to? This is pi r cube 2 by root 3, and you have this 2. So 2 by root 3 and 2 by 3 root 3 is what I have. Or you can say that you can take out 2 by root 3, pi r cube 2 by root 3 common, and what will remain is 1 minus 1 by 3. This is 2 by 3 actually. And from here I'll get V max is equal to what? V max will finally be equal to this expression. This is 2 by 3, this becomes 4 by 3 root 3, or which will become 4 root 3 by 9 times pi r power 3. This is what I'll get, and that is my answer for this question over here. That's the 17th question for us.